Hello students, in previous lecture we have completed the topic basic concepts in geometry from mathematics 2. I have completed two topics, one from maths 1 that is sets and second one that is basic concepts in geometry from maths 2. Today we are going to study about the few concepts from maths 1 and then we will start the topic that is chapter number 2, real numbers from mathematics 1. First of all, we have to remind few concepts that I have already discussed in bridge course program also. Then I am again repeating few concepts, that is the natural numbers. Natural number, all of you studied about that. Natural number is denoted by capital M and natural numbers are nothing but it is a set of 1, 2, 3, 4, 5, 6 and dot dot. That dot dot means there are infinite number of natural numbers. Then the lowest, that the smallest natural number is here, that is natural number. Smallest natural number is 1. And here we can't determine the biggest natural number because there are infinite natural numbers are there. Similarly, the set of whole number, natural number as well as W is a set of whole numbers, and whole numbers are nothing but it is a set of all natural numbers including 0. That means 0, 1, 2, 3, 4, 5, 6 and dot dot. That means here the smallest whole number, that is 0, and the biggest whole number we can't determine because there are also infinite number of whole numbers. Then one more set of number system, that is integer number system. Integers are there and I is a set of all integers. Then you have studied about that. Integers is a set of, that is 0, all positive numbers, that is plus 1, plus 2, plus 3 and dot dot means infinite positive numbers are there, and as well as negative numbers, minus 1, minus 2, minus 3, minus 4 and dot dot, all negative numbers. That means integer, it is a set of numbers, that is 0, all positive numbers and all negative numbers. Here we can't determine the smallest integer as well as the biggest integer because see here, as we move left in the number line of integer number line, then here the number which is left to that number is smaller than that number. That means, for example, minus 2 is left to minus 1, therefore minus 2 is smaller than minus 1. Similarly, minus 4 is left to the minus 2 or minus 1 or minus 3, therefore minus 4 is smaller than minus 3, minus 2 or minus 1. As well as all negative numbers are smaller than 0. That means negative integers. are smaller than 0 and all positive integers are greater than 0. That means here there are infinite number of negative numbers. Therefore, we can't determine the smallest integer, as well as there are infinite number of positive numbers. Therefore, we can't determine the biggest integer. Then see here, there is few orderness between integers that have already discussed in bridge course program as well as in previous standard. For example, see here, -3 is less than 0, as well as -3 is less than 4, because here all negative numbers are smaller than positive numbers. All negative numbers are smaller than 0, as well as we can compare between negative numbers also. That means see here, -3 and -4. In those two integers, -4 is smaller than -3, because on number line, origin to which 0 is related, that is O is the origin, and to the left of 0 negative numbers are there. At equal distance we can write the negative numbers. See here, -4 is left to the -3. Therefore, as we move left, the numbers decreases, value of these number decreases. Therefore, here -4 is less than -3. Then we will discuss about few numbers in bridge course as well as in previous standard, that is rational numbers. And rational number is denoted by capital Q. See here, natural number set, whole number set and integer number set are written in the form of list method. Then see here, whole number are written in list method form, as well as integers are also can be written in the form of list method. And here rational numbers, those numbers we can write by only rule method. That means Q is a set of all rational numbers, and those rational numbers we can express in the form of P upon Q. That means all rational numbers can be written in the form of P upon Q. Whereas, see here, such that P belongs to integer. That means P is a integer. Q is also integer. But here condition is that Q is not equals to 0. That means, see here, rational number set is written in the form of rule method, or it is written by rule method. Then we can write the few examples of rational numbers using this rule. See here, P upon Q form, whereas P and Q both are integers. That means P and Q, it may be any positive number or any negative number, or it may be 0, but Q should not be 0. Here condition is that Q should not be 0. Therefore, we can write few examples of rational number. That is here, 2 upon 3 is a rational number. 5 upon -7 is a rational number. minus 7 upon 2 is a rational number. Minus 5 upon minus 2 is also rational number. See here, 1 upon 4 is a rational number, or 4 upon 1 is also rational number, which can be written like this, 4. That means here 17, which is written like this, 17 upon 1. Here 17 is an integer, but it can be written in the form of p upon q, that is 17 upon 1. Therefore 17 is an integer as well as it is a rational number. Then see here, between 0 and plus 1, between these two numbers, there are lot of rational numbers are there. That means here, in every, between each adjacent neighboring integers, there are lot of infinite number of rational numbers are there. We can write those rational numbers. See here, the number line, whereas all positive numbers as well as negative numbers can be shown on the number line, that is L or N is a number line. Here O point to which 0 coordinates it is related, on equal distance we can take positive integers at the right hand side of 0, that is plus 1, plus 2, plus 3, plus 4 and so on. Similarly, on left to the 0, minus 1, minus 2, minus 3, minus 4 and lot of infinite numbers are there. Then see here, between 0 and plus 1, here plus sign is avoided. That means these are positive integers. See here, these are positive integers. And here minus 1, minus 2, minus 3, minus 4 are negative integers. Then between 0 and 1, there are infinite numbers points are there, as well as there are infinite rational numbers are there. That means each point between 0 and 1 is related with the numbers. As there are infinite points between 0 and 1, as well as 0 and minus 1, there are infinite points as well as infinite rational numbers are there. For example, here between 0 to 1, exactly at the middle, 1/2 number is there. Similarly, we can write many rational numbers which is lies between 0 to 1/2 as well as 1/2 to 1. Then see here, on that number line we can represent any rational number on that number line. Then first of all, see here, those rational numbers we can represent in the form of P upon Q. Then all of you have studied about that rational numbers can be written in decimal form also. That means, for example, 1 upon 2 is a rational number which is written in P upon Q form, and that 1 upon 2 is also written in 0.5. That means it is a decimal form of that rational number. For example, 7 upon 3, it is also written in the form of 2.3333 ... That means it is also written in the form of 2.3 and the repeating decimal number, decimal digit, which is written only once, and the bar sign or dot sign is used. Then see here, there are few concepts which is related with the rational numbers. We are going to discuss about that. Then see here, orderness between rational numbers. That means here orderness means comparison between, that is comparison between rational numbers, Then see here how to compare between rational numbers. Let us consider P upon Q and R upon S are two different rational numbers. Whereas Q should not be 0 and here S should not be 0. Then we can compare between those rational numbers. See here, there are three possibilities between those rational numbers. First one, that is if P into S is equals to Q into R. That means then here P upon Q is equals to R upon S. Then see here, for example, that is here 1 upon 2 is one of the rational number, and here 5 upon 10 is another rational number. Then see here 1 into 10 and 2 into 5. Then 1 into 10, that is 10, and 5 into 2, that is 10. That means 10 is equals to 10. 1 into 10 is equals to 2 into 5. Therefore here 1 upon 2 is equals to 5 upon 10. See here, that means those numbers are equal rational numbers. One more possibility is there. Here if here P into S, it may be greater than R into Q, then here P upon Q is greater than R upon S. For example, see here, if the number which is 2 upon 3, that is rational number, example, that is 2 upon 3 and 3 upon 7 are two different rational numbers are there. Then here 2 into 7 and 3 into 3. Here 7 into 2 is 14 and 3 into 3 is 9. Here between 14 and 9, 14 is greater. Therefore 2 into 7 is greater than 3 into 3. Therefore here 2 upon 3 is greater than 3 upon 7. That means here P upon Q is greater than R upon S. One more possibility is there, that is third possibility. See here, the third one possibility, that is if P into S is smaller than R into Q, then P upon Q is smaller than R upon S. See here, for example, here, that is 1 upon 2 and 7 upon 3. Here 1 into 3 is less than 2 into 7. That means here 1 into 3, that is 3 is smaller than 14. Therefore, here 1 upon 2 is smaller than 7 upon 3. That means that is the comparison or orderness between rational numbers. We can compare between the given rational numbers, which is the biggest or which is the smallest rational number, or the given rational numbers are equal values. Then let us study about the properties of rational numbers. See here, there are few properties which is related with that rational number. That is, we will discuss about that one by one. First property, that is commutative property. Commutative property of rational number. See here, let us consider A, B and C are rational numbers. These are rational numbers. Then what is the commutative property of rational number? See here, we can write the commutative property according to the addition or according to the multiplication of that rational numbers. That means here additive commutative property and as well as multiplicative commutative property. Commutative property of rational number. See here, first additive commutative property, that is if A, B, C are rational numbers, then A plus B is equals to B plus A. Then here multiplicative commutative property of rational number, that is if A, B, C are rational number, then here A into B is equals to B into A. For example, see here, A is a rational number, that is 2 upon 3 plus 1 upon 3. See here, 2 upon 3 plus 1 upon 3. 2 upon 3 plus 1 upon 3 here. Denominators are same. Therefore, 3 upon 3. 2 plus 1 upon 3. That is here 1. Similarly, B is 1 upon 3 and A is 2 upon 3. Therefore, here 1 upon 3 plus 2 upon 3. Here also denominators are same. Therefore, 1 plus 2, that is 3 upon 3. Therefore, here, so 1. That means here this property, commutative property is proved here with the help of example, as well as the same example is taken here, that is 2 upon 3 is one of the rational number into 1 upon 3 is another rational number. Then here multiplication of those rational number, 2 into 1, that is 2 upon 3 into 3, that is 9, as well as here B is 1 upon 3 into A is 2 upon 3. Therefore, here 1 upon 2 upon 3 into 3, that means 2 upon 9. That means here this property is proved by using example of it. Then one more property, that is second property, that is additive associative property, as well as multiplicative associative property. If A, B, C are rational numbers, then here associative property, which is related with the addition, that is here A plus B plus C is equals to A plus B plus C in bracket. Then here in bracket A plus B plus C is equals to A plus in bracket B plus C. For example, see here 1 upon 2 plus 3 upon 2 plus here 2 upon 2, or here A is 1 upon 2 plus in bracket B is 3 upon 2 plus 2 upon 2. Then see here, first we have to solve the bracket. 1 upon 2 plus 2, 3 upon 2, denominators are same, therefore here 3 plus 1, 4 upon 2 plus 2 upon 2. Here also denominators are same, therefore 4 plus 2, that is 6 upon 2, that is 3. As well as here, first of all we have to solve the bracket, therefore here 1 upon 2 plus, here denominators are same, therefore 3 plus 2, 5 upon 2. Here also denominators are same, therefore 1 plus 5, that is 6 upon 2, that is 3. That means here this property get proved here with the help of example. Here A into B in bracket into C is equals to A into in bracket B into C. Let us consider the same rational numbers to prove this property. Here A is 1 upon 2 into B is 3 upon 2 into C, that is 2 upon 2. Then here A is 1 upon 2 into in bracket 3 upon 2 into 2 upon 2. Therefore here 1 upon 2 into 3 upon 2, that is, see here 3 into 1, 3 upon 2 into 2, 4 into 2 upon 2. And here again 3 into 2, that is 6 upon 4 into 2, 8. See here the example from this side, that is 1 upon 2 into 3 into 2 into 2 into 2, that is 3 into 2, 6 upon 2 into 2, 4. Therefore here 1 upon 2 into 6 upon 4, that is 6 into 1, 6 upon 4 into 2, that is 8. See here 6 upon 8, and here is also 6 upon 8. That means this property is also proved here. Similarly, additive identity property as well as multiplicative identity property. Identity property as well as multiplicative identity property. Here A plus 0 is equals to 0 plus A, and here A plus 0 or 0 plus A is equals to A. Then see here any rational number in which 0 is added, then the result is that rational number. Then see here, for example, 2 upon 3 plus 0 is equals to 0 plus 2 upon 3. 2 upon 3 plus 0, that means 2 upon 3. 0 plus 2 upon 3, that is 2 upon 3, and that is the EA, that means 2 upon 3. That means this property is known as additive identity property. That means the addition of any rational number with 0 is the same rational number. Similarly, see here, any rational number when multiplied by 1, then that rational number is obtained here. That means here a into 1 is equals to 1 into a is the same rational number. For example, see here, a is 2 upon 3 into 1. Any rational number is multiplied by 1, then answer is that the same rational number. Similarly, 1 into any rational number is the same rational number. Then see here is the same rational number. That is the multiplicative identity property. Then last one property, that is additive inverse property. Additive inverse property as well as multiplicative inverse property. Multiplicative inverse property. Then see here, all of you studied about that. If a is a rational number, then minus a is the additive inverse of that a. For example, 2 is a rational number, then additive inverse of that 2 is minus 2. Similarly, 5 upon 2 is a rational number, then minus 5 upon 2 is a additive inverse of that 5 upon 2. If minus 7 upon 3 is a rational number, then additive inverse of minus 7 upon 3 is 7 upon 3. If 5 upon 3 is a rational number, then minus 5 upon 3 is a additive inverse of it. Then if the addition of two additive inverse, it is always 0. That means here a plus minus a is 0. That means here 2 plus minus 2 is 0. Similarly, 5 upon 2 plus minus 5 upon 2 is 0. Here also minus 7 upon 3 plus 7 upon 3 is also 0. As well as 5 upon 3 plus minus 5 upon 3 is equals to 0. That is the additive inverse property. Similarly, multiplicative inverse, all of you studied about that. Here, if a is a rational number, then multiplicative of inverse of a is 1 upon a. And here, for example, 2 is a rational number, then 1 upon 2 is a multiplicative inverse of it. If 3 upon 2 is a rational number, then 2 upon 3 is a multiplicative inverse. If here minus 7 upon 2 is a rational number, then minus 2 upon 7 is a multiplicative inverse. That means here reverse multiplied number is a multiplicative inverse of it. And here the property, see here, multiplication of multiplicative inverse is always 1. That means here a into 1 upon a is equals to 1. That means here 2 into 1 upon 2 is 1. Here 3 upon 2 into 2 upon 3 is 1. Here minus 7 upon 2 into minus 2 upon 7 is 1. That is the few properties which is related with that rational numbers, and those properties are proved by with the help of examples given here. Then you may solve the examples from practice set which is related with those properties of rational numbers, as well as the examples which is based on comparison between rational numbers or their orderness of the rational numbers. Thank you.